Alright, third topic, random topic, is superconductor. I have no idea what that means. I know it has something to do with chemistry. Let me just start with a disclaimer. I know almost nothing about electricity. Superconductivity. Let's see. A part of series electromagnetism. Superconductivity is a set of physical properties observed in certain materials where electrical resistance vanishes and magnetic flux fields are expelled from the material. I believe electrical resistance causes heat. Conductance versus resistance. The reciprocal quantity is conductance, measuring ease with which an electric current passes. Electrical resistance shares some conceptual parallels with mechanical friction, and magnetic flux fields are expelled from the material. The shape of a magnetic field produced by a horseshoe magnet is revealed by orientation of iron fillings sprinkled on a piece of paper above the magnet. Magnetic field is a vector field that describes the magnetic influence on moving electric charges, electric currents, and magnetic materials. In physics, specifically electromagnetism, the magnetic flux, the action or process of flowing or flowing out. Thesaurus says movement, motion, transfer, course, passage, current. The thesaurus gives you a richer meaning. It reminds you of other concepts that are closely related to the word. In physics, specifically electromagnetism, the magnetic flux through a surface is
integral.
The surface integral of the normal component of the magnetic field B over that surface. It is usually denoted phi or phi B subscript. The SI unit of magnetic flux is the Weber, named after Wilhelm Eduard Weber. Together with Carl Friedrich Gauss, invented the first electromagnetic telegraph. See, this is why we click on the links. A flux density of 1 Weber per square meter is 1 Tesla. Nikola Tesla. Tesla, derived unit of the magnetic B field strength, also magnetic flux density in the International System of Units, SI. He's so glamorous with that stance. The death of Nikola Tesla. Accident. You know, it's easy to believe conspiracies because of his influence and because of his research, not that he wasn't cancelled for his work in methods that could potentially displace the model of production of electricity. The FBI ordered to seize Tesla's belongings. John G. Trump's report concluded that his thoughts and efforts during the past 15 years were of a speculative, philosophical, and somewhat promotional character, often concerned with the production of wireless transmission of power, but did not include new sound workable principles or methods for realizing such results. Continued, in a box purported to contain a part of Tesla's death ray, Trump found a 45-year-old multi-decade resistance box. 3 days after his death, the mayor read a eulogy over WNYC radio, while violin pieces Ave Maria and Tamo Daleko were played in the background. Yeah, that Trump. High voltage, high frequency power experiments, alternating current, and the CGS, back to our topic, unit is the Maxwell. Magnetic flux is usually measured with a flux meter, which contains measuring coils and electronics that evaluate the change of voltage in the measuring coils to calculate the measurement of magnetic flux. The magnetic interaction is described in forms of a vector field, where each point in space is associated with a vector that determines what force a moving charge would experience at that point. Since a vector field is quite difficult to visualize at first, in elementary physics one may instead visualize this field with field lines. Back to the superconductor. Superconductivity is a set of physical properties observed in certain materials where electrical resistance vanishes and magnetic flux fields are expelled from the material. Any material exhibiting these properties is a superconductor. Unlike any ordinary metallic conductor, whose resistance decreases gradually as its temperature is lowered even down to near absolute zero, a superconductor has a characteristic critical temperature below which the resistance drops abruptly to zero. An electric current through a loop of superconducting wire can persist indefinitely with no power source. The superconductivity phenomenon was discovered in 1911 by Dutch physicist Heike Kamerlingh Onnes. Like ferromagnetism and atomic spectral lines, superconductivity is a phenomenon which can only be explained by quantum mechanics. It is characterized by the Meissner effect, which is the expulsion of a magnetic field from from a superconductor during its transition to the superconducting state when it is cooled below the critical temperature. Expulsion will repel a nearby magnet. The complete ejection of magnetic field lines from the interior of the superconductor during its transitions into the superconducting state. The occurrence of the Meissner effect indicates that superconductivity cannot be understood simply as the idealization of perfect conductivity in classical physics. In 1986, it was discovered that some cuprate perovskite ceramic materials have a critical temperature above 90 Kelvin. Such a high transition temperature is theoretically impossible for a conventional superconductor, leading the materials to be termed high-temperature superconductors. The cheaply available coolant liquid nitrogen boils at 77 Kelvin, and thus the existence of superconductivity at higher temperatures than this facilitates many experiments and applications that are less practical at lower temperatures. Periodic table of superconducting elemental solids and their experimental critical temperature. Periodic table of superconducting binary hydrides 0 to 300 GPa, theoretical predictions indicated in blue and experimental results in red.